My name is Kelly Hall. I'm a marketing coordinator for ALS North America, and I will be facilitating this webinar today. Before we begin the presentation, I do have a few helpful notes. If you are having any technical issues with our webinar platform or questions, please type your message or question in the chat pod located at the bottom right of your screen. You can also select the hand icon to notify me of your status, and I can assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is David Doyle. David Doyle has been in the petroleum business for 44 years and has a wide range of knowledge in lubricant and fuel products and relevant test methods. His experience includes operation and terminaling activities, lubricant blending, and laboratory management positions for major and independent oil companies, as well as independent laboratory businesses. He has his CLS, OMA1, and OMA2 accreditation through STLE. Currently, David supports the Global Laboratory Network for ALS Tribology and manages branded programs for major lubricant companies and original equipment manufacturers. His activities include technical support and development of value-added tools and services. David, thank you for taking your time to deliver this presentation today. I will go ahead and turn it over to you.
All right. Hello, everybody. Thank you for taking some time out of your day today and to attend this webinar. Today, we'll speak about how changes in diesel engine oil technology reflects the use of acid number and oxidation number versus the historical use of base number when testing in-service diesel engine oils. Formulations and how we look at in-service engine oil performance and service life has evolved over the years. The agenda for this presentation includes the following: changes over the years in the engine oil formulations, historical relevancy of base number, changes in acid number and used diesel engine oil, the role of additives, what to look for in today's diesel engine oils for monitor and service life, and historical perceptions and changes in the market. Diesel engine oil formulations have continued to evolve over the years in order to meet technology requirements, which include lower base numbers, higher detergency, lower sulfated ash, and increased use of lower viscosity oils. Diesel engine oil formulations base number represents alkalinity reserve or base reserve, which is normally associated with acid neutralization. Historically, the base number primarily targeted neutralizing the highly corrosive sulfuric acid created when the combustion process reacts with sulfur. Base number in the past has been a key measurement in monitoring engine oil life. In the past, diesel engine oil performance requirements dictated higher base numbers. Today, diesel engine oil starts out with a lower base number and have a better retention properties. So back in the day, diesel engine oil formulations would have a base number as high as 12 or 13 by ASTM D2896, and this goes back a number of years. Today, diesel engine formulations now start out with a base number closer to 9 or to 10.5. Evaluating base number related to used engine oil analysis has changed over the years. The old rules no longer apply when it comes to using base number to monitor engine oil life. An old rule used to be condemning limit of half the new oil value. As years went by, base number flagging limits have gradually been reduced. Base number flagging criteria and acceptance for used oil is much lower than seen in the past in today's world. This includes many of our proprietary branding testing programs as far as what the limits they want to have applied. Today, ALS uses a base number condemning limit of 2.0 for abnormal to flag base number test results. Some proprietary branded testing programs use an even lower limit due to today's relevancy of using base number in testing. Generally, commentary on our reports when the base number is 2.0 or less is base number is low, the recommended limit. Generally, if nothing else is an issue, we're not going into more detail than just saying the base number is low and everything else looks fine. Further to this, ALS uses test method D4739, which is preferable to testing in-service engine oils. Just as a note, we use a test method that's actually more relevant to using for in-service diesel engine oils. The following slides have several examples of test reports where base number was flagged, yet no other issues were present in regards to oxidation number or viscosity and wear metals. The reporting shown are good examples of the value of quality oil information, which is important when submitting a sample. So I'm not sure if this is how easily people can see this slide, but really the only thing flagged on this report here was a low base number of 1.3, and as you can see, all of the parameters as far as wear metals and oxidation, viscosity were all fine. So we just noted base number was low, everything else looks fine. In this report, we see that previous testing shows the base number was within acceptable limits, yet copper and aluminum are noted. The most current test shows a reduction in these metals while the base number is flagged as being below the limit. So on this report, there's a historical trend. And you see on the right, the two historical test results were flagging some issues with copper and potassium, generally due to the cooler situation. The base number's above the limit, but we see a problem here. And then the base number really didn't have a lot of relevancy as far as the condition of the situation with the sample. The most recent sample showed that the situation was resolved as far as wear metals and contamination, and everything looked fine except the base number was now below the limit. So we're seeing examples of how relevant is base number to the condition of the engine and the oil itself. Again, in this report, all of the test parameters are within acceptable limits with the exception of the base number being below flagging limit. Now, acid formation in in-service diesel engine oil has changed over time. Regulations and formulations have dramatically reduced the sulfur content in diesel fuel and the latest API engine oil classifications. So there's a lot less sulfur in the fuels, as everybody's probably aware of, but there's also a lot less sulfur in the engine oils being used today. The creation of highly corrosive sulfuric acid has been significantly reduced in diesel engine technology simply because of the reduction in the sulfur content. So current API CK4 engine oils specify 500 ppm sulfur max, which is probably, previous API classifications could have had 10 times the sulfur. Ultra low sulfur in diesel fuel limit, the limit there is 15 ppm max. So what we're seeing is all this reduction in the sulfuric acid in the sulfur leads to a significant reduction in the creation of the sulfuric acid, which also leads to a reduction in what we're looking for with base number and what the base number had historically been used for. The main changes in the acid formation of in-service engine oils, well, the main culprits that affect the creation of acids in engine oils today are there are weaker nitric acids being created by the NOx compounds reacting with recirculated exhaust gases. There's also weaker organic acids formed during combustion and oxidation. Nitric acid and organic acids that are created are much less corrosive and reactive than sulfuric acid, and And these weaker acids today are a large source of what type of acids are showing up in used engine oils. As far as the role of additives and formulations that continue to evolve, there's been a shift in the balance of additives. Historically used oil, historically the additives used in diesel engine oil formulations um, would have a different configuration of additives, and we're using similar additives today. It's just they've been reconfigured and the balance is a little different. So this includes detergency additives that play a critical role in diesel engine oil formulation. Additives such as calcium and magnesium, historically used for base number, also play a dual role in providing detergency properties in engine oils. Today's additives focus on providing improved levels of detergency, and less focus on the role of the base number in neutralizing acids. Continuing with the role of additives in today's formulations, decreased metal organic additives, and this would be your calciums, your zincs, phosphorus, etc. The reduction benefits in helping to lower sulfated ash levels into today's diesel engine oils. Sulfated ash levels, when they're too high, can create corrosive hard deposits in the piston crowns, which are abrasive. So this allows for reduction in the creation of those deposits. Dispersancy additives performance is key to managing contaminants from recirculated exhaust gases. So with the reduction in the metal organic additives, a lower sulfated ash allows for reduced deposits, which can cause ring zone and upper piston wear. And improved dispersancy additives play a critical role in managing contaminants that are a result of the recirculated exhaust gases. So today, what we look for in monitoring diesel oil service life is a little bit different. There are principal parameters that we look for when testing in-service diesel engine oils. Key factors to monitor while testing in-service diesel engine oils include looking for high oxidation, unacceptable changes in the lubricant viscosity, and increasing wear and corrosive metal content. So with today's oils, with the technology and what the lubricant manufacturers and the engine oil manufacturers are looking for, acid number and oxidation have become a more relevant tool in testing used diesel engine oils. Acid number is complemented by monitoring oxidation number and viscosity. So you get a nice matrix when you combine acid number with the oxidation number and viscosity in judging the service life of an engine oil. Monitoring the acid number trends, oil aging, and monitoring service life. Using acid number along with oxidation number and other test results provides a more complete picture of an engine oil service life and drain interval requirements. The test method used for determining acid number is ASTM D664. So as far as the use of acid number monitoring diesel engine oil service life, how is acid number relevant to engine oil service life? A high acid number does not mean the engine oil has turned acidic. First of all, acid number increases due to reactions with oxidation and oil degradation compounds. That's where you see the change in the increase in the acid numbers due to these chemical reactions. As oxidation byproducts are formed in the engine oil during service, the acid number will increase. Within ALS, acid number is flagged per the following protocol for diesel engine oils. And so unless we have special requirements from our customers, what ALS will do is flag an acid number. We'll flag caution at a 4.0. We'll flag a sample as abnormal at 5.0 and 6.0 as severe. And many times we will flag acid number in combination with other test parameters that look at the oil service life. A proper evaluation of the acid number in monitoring diesel engine oil service life is also dependent on complete sample information. Getting back to when a sample is submitted, if we have complete information, it allows us to provide a better analysis and a more complete report. The use of the established flagging limits for acid number can have some qualifying application. Having complete oil information is valuable in assessing product performance. ALS will, when flagging acid number, will relax some of the flagging criteria if it's between 4 and 5, and viscosity and oxidation are fine, or the oil was changed at the time of sampling, which is included in the information on when submitting a sample, or if sample information provided is limited. So as I mentioned a minute ago, we will use some qualifying factors depending on the information provided and other test result factors. So how is oxidation number relevant to engine oil service life? The oxidation number is primarily monitored by increases in the trending analysis. It's a trending tool. The increase in the trending of the oxidation number is due to increasing oxidation in oil degradation compounds. As oxidation byproducts are formed in the engine oil during service, the oxidation number correlates with increases in acid number and viscosity, so it provides a good complement. Flagging of oxidation number is reliant on trending, as I just mentioned. Oxidation is reported in absorbance per centimeter by FTIR infrared instrumentation. Generally, when a test result reaches 35 to 40 absorbance per centimeter, the oxidation number is noted on the report. This is for diesel engine oil testing. Oxidation is best used when correlating with other test results. The same oil deterioration properties which causes increase in the oxidation number also contributes to the increasing acid number. Again, having complete oil information is valuable in assessing product performance. Now, in this slide, the top chart shows how base number correlates to oxidation number on various heavy-duty diesel engine oil samples. The bottom chart shows how acid number correlates to oxidation number on the same samples. So you see a good correlation trend. And it tends to be a little bit tighter when we're correlating oxidation to acid number. The correlation data for the acid number comes in tighter than the base number correlation data. We see that acid number starts to reach a flagging limit when oxidation number gets around 35, as noted previously, which tends to be the level at which we take notice. When using oxidation number to complement testing for oil service life, again, trending of the test results is the key factor. So this is real good data in showing how the value of using the acid number and oxidation number in monitoring the engine oil service life, as opposed to what we've done in the past using base number. And customers are still using base number, don't get me wrong, but the change from base number to oxidation and or acid number is the trend that's happening in the market today, and a lot of the oil companies are pushing this. So, we have historical perceptions that have gone on for decades in the market as far as what is relevant to testing in-service diesel engine oils. The market has been familiar with looking at base number to monitor oil condition for decades, but many people are not familiar with what base number is actually meant to measure. They just look at that number, looking for it to go down to a certain level, not really not always understanding, well, what is that number? What is base number actually meant to do? Which is the oil's ability to neutralize highly corrosive acids, primarily sulfuric acid. Again, which is greatly reduced in today's oils. The need for this has been greatly reduced. So the challenges in today's market, changing the perception of the relevancy of base number. People still have a comfort zone that is developed over decades. And not everybody is familiar with the concept of relying on acid number and oxidation number. So this is why we wanted to have this webinar to provide a little bit of insight as far as what's going on with today's technology in formulations and engine technology, and how the testing has begun to change in relation to that. We have some additional information that's available. We can provide. I realize this is on our webinar slide, but we have eSource technical articles. We can provide that information if you're not already familiar with that. It's a good library of resource information. We also have a lot of information on our website. If you're not already registered for receiving data and reporting on our website, we can get people set up for that. And there's technical reference material also on the website that's pretty good. And we also have technical bulletins that are available by request. So I'm just mentioning that, just as an FYI, in case anybody's wanting some further technical information. So right now, I'll leave it to the group to provide any questions they may have, and I appreciate your time today.
Thank
Back
you,
to you,
Dave.
Kelly.
Thanks. Yeah, we will go ahead and open up the forum for questions now. You can, again, write out your question in the chat pod section at the bottom right, or you can raise your hand if you want to ask David a question. I will give everyone a few moments to type in their questions. And David, during the presentation, someone had asked, was it centimeters or millimeters in regards to, I believe you're on slide 10 or 11.
For the oxidation numbers?
I believe so. I'm not quite sure. It was
Yeah, it's
yes.
absorbance per centimeter.
Okay.
And instrumentation and labs can report absorbance per millimeter, which is not the standard in our industry, but it's just a matter of moving the decimal place over to the left a couple places. So or by a factor of 10. And so, some people may be familiar with absorbance per millimeter. The industry standard is to report an absorbance per centimeter, and that's what you'll see on the report.
Okay, thank you.
Hopefully that answered the question.
Yes, and I just wanted to let everyone know that this webinar presentation is being recorded, and all participants of this webinar will receive a follow-up email once this recording is available to view. We do post all of our webinars on our ALS Global website and on our ALS YouTube channel in the webinar playlist. Again, we'll just still wait for a couple more minutes to see if there's any additional questions coming in. And David, he said that on the report, it looks a little different than what you had mentioned. So maybe that's something we can look at after.
Sure.
We had another question come in. It said, what method is used to measure the oxidation?
I don't have it's an ASTM method. It's for FTIR. I don't have that off the top of my head right now, but it's a standard ASTM method. So I'm going to go back to that report. You said it was slide 11.
Someone said E2414. That might have been the method. Does that sound familiar?
Repeat that, please.
Someone had just typed in E2414. That
Yeah,
might be
that's
the
that.
method that he was just
Yeah, that is one
okay.
of the methods, and there's also a committee D method also. But yeah, that is a relevant method. So that's good. That's good. So I'm good. I'm back at one of the slides, and it is showing the E2412 method, and it shows the correlating D7414 method on the test report. If you can see that, and I see what you're saying as far as absorbance per millimeter. So we'll need to get with somebody on that because that's absorbance per centimeter. I'll
Okay.
confirm all of that.
Thanks,
That's a
David.
good question.
There was another question that came in that says acid and oxidation are relevant for today's engines and oils. Is this true for older engines with these same oils?
Um, Not so much. It just depends. It really depends on the fuel that they're using, um, and it also depends on. It depends on how old the engine is because these changes have been going on for quite a while. So, I'm going to backtrack a little bit on my original comment. Um, if we're still using lower sulfur um, oils and fuels in an older engine, and older engines are using EGRs, they've been around for a long time. Yeah, there is still quite a bit of relevancy to using oxidation and acid number.
And let me see really quick. Um, that person responded with low sulfur fuel, no DEF. Was
As
that?
far as
I'm not quite sure. That was all the
well, okay, I'm not really sure what the question is with um I'm assuming if somebody's using the DEF as opposed to other treatment systems such as the EGR, whether if it's still relevant to DEF systems for treating exhaust gases, and I would say yes.
okay. Miss, I think there was one more question that came in. It says you asked about how old the engines are. He wanted to say that the engines were prior to 2010.
Um, Getting back to what I was saying, if they're still using the lower sulfur uh, engine oils, if they're using the ultra low sulfur diesel fuel, and if they're using an EGR system, it's relevant to monitor with acid number and base number, and uh, not worry so much about the base number. Uh, Excuse me, to monitor with oxidation number and acid number, not worry so much about the base number.
Let me see
It's
what
all
he.
relevant to how much sulfur is being introduced into that combustion chamber.
He said thanks. So I think that answered his question.
Okay.
I don't see any additional questions at this time. I did have a couple questions about the WebTrieve mobile app. The people who have requested information on that, I'm going to send you a video about that. We actually have had a webinar on the WebTrieve mobile app, and it will answer all those questions for you about the functionality of that. And again, you can find those videos on our ALS global website as well as our YouTube channel. They're both listed there. We had that, I want to say, back in the beginning of July. Other than that, I want to thank everyone for attending our webinar Wednesday today. And thank you, David, for presenting. And we'll see y'all next time. Thank y'all again. Have a great week.
All right. Thank you, everybody.